Well, a warm welcome to everyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook. Grab a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have another SAT style problem from the topic of algebra. More specifically, kind of an algebra 2 topic. You'll see that we have a third degree polynomial here. We have a cubic. All right, and I do reveal the answer choices this time. That's because one of the main concepts that we use to solve this problem is going to basically directly address some of these answer choices. And so I wouldn't normally just encourage teaching you process of elimination, but if it's motivated directly from some kind of math concept, then sure, we'll go over that. So as usual, give yourself about 2 minutes to solve this problem. You can pause the video, give yourself some time. Maybe you can work through the process of elimination as well. And then when you're ready, unpause the video. You can check out how we did it here. All right, let's get started. Now, one of the first things to address is the fact that it asks about the total number of solutions. So here's a fact about polynomials. That fact is that if we have an nth degree, if n is the degree of the polynomial, then we have n roots. Total number of roots, or solutions, in other words. The thing is, some of those roots might be imaginary, some of those might be real, as suggested by the answer choices. Well, we need to have n roots for an n degree polynomial. Right. Another thing we have to be aware of here is that imaginary roots, complex roots they also call them sometimes, and really this goes for any kind of irrational roots, so like radical roots. Imaginary / complex roots, they come in pairs. Okay, so this immediately allows us to address one of the answer choices as obviously wrong, like it's illogical. We cannot have one imaginary root. They have to come in pairs. So we either have 0 or we have 2 or 4 or 6 or yada yada yada. We cannot have one imaginary root. That does not even make sense. So we didn't have to do any solving to determine that that's wrong. It just doesn't make sense. Another thing to address is option D. We need to have a total of 3 roots. So we can't just have one real root and have 0 imaginary roots. We could have one real root and 2 imaginary roots because they come in pairs. This is possible. I'm not saying that's right, but it's possible. And we could also have 3 real roots. So yeah, you get the idea. Well, now it's time to use the given information. Use the fact that x plus 3 is a factor. We're going to use the process of synthetic division. That's how we use the factor. We can use synthetic division to divide a factor, or rather divide by a factor, and that will leave us with some kind of knocked down polynomial. So this cubic polynomial will get knocked down to a squared or quadratic polynomial. And we're going to put -3 in the box. If you're not familiar with the synthetic division process, just remember that we use the coefficients of the descending powers of x, which means we have an x cubed coefficient, an x squared coefficient of 0. Be aware of that. There's no x squared term. It just goes straight to the minus 26x. So we need a placeholder 0 as its coefficient, and then we have -26, and we have 30. Follow the process. If you're not familiar with the process of synthetic division, you got to go review it. If you haven't hit that part of Algebra 2 yet, then my apologies, but you're going to have to learn some of this stuff because it's probably going to come up on the SAT. All right, so let's drop the number down, multiply by the number in the box. That gives us -12. Add those together, put that number down, multiply by the number in the box. It's going to be a positive 36. Add those together, we get 10. multiplied by the number of the box, we get negative 30, which should always cancel out perfectly to a 0 remainder if indeed this is a factor that we're dividing, which we know it is. We're told that it is. So that means that the x plus 3 is being multiplied by this polynomial, which we're going to call 4x squared minus 12 on the x plus 10. Okay. Very interesting indeed. So we have this quadratic, and the question is, how many solutions do we have? We know that x plus 3 is equal to 0. That gives us one solution of x equals negative 3. But what about this quadratic here? The question really comes down to this core skill. This is how we're going to ultimately determine the number of imaginary compared to the number of real zeros. It's clear from the answer choices that there are going to be some combination of imaginary and reals. It's possible that we have no imaginaries. That is possible. It's possible that we have two imaginaries. That's also possible. So this is coming down to how we figure that out. And we use something called the discriminant. The discriminant tells us the number of solutions. It doesn't exactly tell us the number of solutions with this little formula that I'm going to show you. You might remember this, or you should remember this. We use b squared minus 4ac. And of course, the a, b, and c are referring to the coefficients in order, just like a, b, c is in order. So the coefficients of 4, negative 12, and 10 are our a, b, and c values. And the b squared minus 4ac, it comes from the inside of the quadratic equation. It's the part inside the square root, which is actually directly why it is responsible and capable of informing us whether or not this quadratic equation has some imaginary roots, or if it has two real roots. We'll see. Now we're going to calculate b squared minus 4ac, so that's negative 12, but it's squared, minus 4 times 10, and this is 144, pretty big number, but it's minus 160, and this is a negative 16, which doesn't mean that much in terms of its value being large or small. Negative 23 versus negative 16 versus negative 1, these all tell us the same result. Because this is less than 0, if the discriminant is less than 0, then the quadratic equation responsible for that has two complex or imaginary solutions. It does not have real solutions. If we got a positive number, any positive number, we would have two real solutions. And if we got exactly 0 on the dot, we would only have one solution from that. Okay, so we have two complex solutions, and we clearly have one real number solution. That's x equals negative 3. So the correct answer here is C. All right. Oh, of course, we're able to eliminate option E as well. Those don't add up to 3. So really, just from using this principle of nth degree polynomials having n roots total, which is the sum of the imaginary and real roots, we can just eliminate some answers that don't add up to 3. Now, realistically, I don't think that on the SAT, you're going to be able to eliminate 3 options from that. You'll probably only be able to eliminate 1 or 2 options. So maybe I made it a little bit too easy, but it was really just to have several different wrong answers, and I wanted to be able to demonstrate this concept of nth degree, n roots, and also the concept that imaginary or complex roots, as well as radical roots, irrational ones, they come in pairs. Okay, I think that's enough blab out of me. Keep studying for your SAT. I'll see you guys next time.